PST is a GUI for supporting the preservation planning process. Curators can use it to design cost-optimal preservation network model. To create a PNM like this one in PST involves using the visual objects to draw the graph and input information using simple editors like this one. To start with, we create a new preservation project and we call this demo. PST provides various extension points for users to plug in their own serializer or PNM ontology profile to customize the application. To build a PNM model, we could do it from scratch and use the new option, or to save times and efforts, we could reuse existing preservation solutions. The import functionality allows us to share PST objects, and for the demo, we will reuse an existing PNM from another project, and we'll also call this demo. We have the options to import all the associated artifacts with the graph, and we chose the default. Now we will update this model to demonstrate the key PST features. First, we will create a simple dependency between two digital objects. We say that to preserve this XML specification for the long term, we also need to preserve another digital object, and we'll call this unit code specification. We want to capture the preservation cost for doing this. We say this cost us about £100 to do so, and we also want to add a risk that we know about this object, and we say that there is a chance that this may become obsolete, and we'll add this risk to provide more information. And we say that there is a 20% chance for this to happen. Why? Because I have read an article about this, and now I'll add a link to this article for documentation purposes. Then we need to connect up the two objects. The relationship property comes from the PNM ontology, and it controls what are allowed between the selected parallel ontology classes. Next, we want to describe the purpose or what objective this relationship fulfills. So we can either create a new objective, or we could reuse an existing one. To save time, we just select an existing one. Next, we want to demonstrate the alternate or logical OR relationship. To make our PNM more robust, instead of just preserving the Windows version of the PDF viewer, we want to add the Linux version as an alternative solution. First, we delete this simple relationship. To save time, we will copy the Linux object from another graph. We paste this in. Then we need to create the relationships. We will connect them up from source via the alternate object to the target. As Windows is our preferred option, we will set a decision to reflect this. We could add information in using the editor, but most importantly, we want to quantify the consequence to our PNM if we failed to preserve this Windows PDF viewer. We say this will only cause a partial failure because we still have the Linux version to fall back upon. Now, the composite or logical AND relationship is very similar to the alternate relationship. It's used in a case when preserving one digital object requires two or more other digital objects. and is created in a similar way to the alternate object. Now I have a fairly complete PNM, and I'm keen to share this with my colleague and get some feedback. So I will save it as an image file. Now this image file is ready for me to email, and this concludes our walkthrough of the key features of this PST prototype. Thank you.